Hello, welcome back. In this class, we are going to look at data types and the scales of measurement in statistics. This is very important while you are collecting your data, while you are entering data into the software, and also analyzing your data. Let's see what we have here. Data and variables. Data is collection of facts, as we have said, and this fact can be in form of audios, in form of videos, in form of visuals, in form of measurements, observation that have been collected and recorded for the purpose of decision making. So when you hear of data, it should be for the decision making. The purpose that the data have been collected is for decision making, and it can take any form, both structural form like you see in Excel or so on, and also it can be in unstructured form like you have videos and audios and so on. So that is data for you. What is variable? Variable is attribute. It is characteristics. It is the features of an entity that you are having in your study. So when we are talking of, for example, an entity being a person, what can you study of person? You can study person's age, you can study person's gender, you can study person's income, and so on. If the variable you are studying or the entity you are studying is a book, the characteristics, the attributes, the feature of a book can be the year of publication, the publisher, the author of the book, and so on. So variable is an attribute, characteristics, feature, like gender, height, date of publication, and so on. Of an entity, it is now characteristics of an entity. Entity can be a person, a book, and any other object that you can think of that the study is interested in. So by now you should be understanding variable. All right? So data classification, we classify data according to the nature, we classify data according to data source, where data lives, and the structure of the data. We have quantitative and qualitative data. When we talk of quantitative data, this is the data that has been the measures. For example, age, for example, the height, for example, the weight. These are quantitative data. They are quantified. We have qualitative data. Qualitative data are the description of the characteristics of a subject. For example, when you talk of color of someone, like black, Asian, and so on, in that case, you are not measuring anything. You are just giving the description. Most of the time, qualitative data are textual or string data. Let's go to classification of data according to data sources. We have primary data and we have secondary data, mostly. The primary data is the data that is collected for this specific project. And secondary data is the data that have been collected for other projects. It can be within this organization or outside of this organization. And now we are using it for different purpose. Secondary data. We again classify data according to where data lives. We have internal data, the data that lives within organization database, organization data warehouse, data lakes. That is internal data. And if data lives outside of our organization, we have it as external data. We classify data according to structure. We have structured data and we have unstructured data. Structured data is the data that have been structurized with rows and columns. Columns being giving us, or the first row giving us the description of the variables, and rows giving us now the cases. In that case, you are dealing with structured data. Unstructured data is the data that have no given structures. For example, when you talk of videos, when you talk of audios, there is still data, but now this data is very unstructured. So these are the main classification of data. you can have the reading below here that we have described. But let me focus on qualitative and quantitative data. As we have already described, qualitative data, which we also call categorical data, are the qualities of the subject of the study. Qualitative data or categorical data can be divided further into nominal or ordinal in the scale of measurement. We are going to look at the description of nominal and ordinal scale of measurement in just a few. We have quantitative data. Quantitative data are the information of the subject of the study that can be measured. For example, the salary, the job experience in the number of years, and so on. And numerical data are divided into two types. We have discrete and we have continuous. Discrete data is the whole number that cannot be divided into parts. For example, if we are talking of the student who have sat for CAPSEA exam this year, you cannot have 2,000 and a half students. You either have 2,000 or 2001. Same with the insurance claim. You can either have over a month or over a year. You can either have an insurance claim for this year as 2000 or 2001. It is the same for the number of loan default. You can either have an individual, 10 individuals who have defaulted the loan this month, or 11 individuals. You cannot have 10 and a half. So these values, these data are the data that we call discrete data. And of course, this data should be following discrete distributions for statistical analysis. We have continuous data. These are the data that can be broken down: height, weight, temperature, money. So these are the continuous data because they have points and they can be divided. For example, if I say my weight is 65 kgs, I mean I weigh 65 point something. It can never be even 65 at any point exact. So that is why we have continuous data. And continuous data can further be divided into interval and ratio, which we are going to look into the details when we go to the scale of measurement. All right, these are the examples that we have given there and the definition that I've already talked about. Now allow me to talk of now the scale of measurement. Very important while you are dealing with your data. Measurement is assignment of number to objects or events according to the rule. So every measurement have some rules. The fact that numerals can be assigned under different rules lead to different kind of scale of measurement. Scale of measurement is how variables are defined and categorized. Who came up with the scale of measurement? Psychologist Stanley Stevens, developed 4 common scales of measurement: nominal, ordinal, interval, and ratio. These are the ones that we are going to live with throughout our statistical data analysis: nominal, ordinal, interval, and ratio. And this has been brought out by the properties like identity, magnitude, interval, eco-interval, and minimum value of 0. So let's talk of these properties of measurement. Identity. Identity is just to identify, to give it a label. It doesn't have any meaning. Identity refers to each value having unique meaning. All right? When we talk of magnitude, magnitude means that the value have an ordered relationship to one another. Right? So there is a specific order in the variable, magnitude. Equal interval. Equal interval means that the data point along the scales are equal. So the difference between data point 1 and 2 and 6 and 7 are the same. A minimum value of 0 means that a minimum value of 0 means the scale has true 0 point. The degrees, for example, can fall below 0. The degrees of the temperature, can fall below 0 and still have meaning. But if you have a way nothing, then nothing exists. You say we say an object is anything that has mass and occupies space. What if you say I weigh 0? Anyway, let's go forward. So let's look at the scale of measurement. By understanding the scale of measurement of the data, the analyst can decide on the type of statistical analysis to perform and model to develop. In fact, it is not about understanding the statistical test. It is even about understanding the input. It is about understanding data entry. It is about understanding data coding. So this is the basic that we should all know before we even create, go to the field. The type of data that we collect, the scale of measurement each variable should be taking. Is this variable nominal, ordinal, ratio, or interval? Let's look at now the nominal scale of measurement. Are used for labeling categorical data or categorical variables without any quantitative value. Nominal scale can simply be called labels. We just label categorical values. For example, if I have a variable called gender of the student that I'm studying, I can say let 1 represent male, let 2 represent female. I can also say let 5 represent female and 6 represent male. It doesn't matter. It's just the label. Alright? It is just for the simplicity I use 0, 1 or 1, 2 and so on. I can also have for the gender, let 0 represent male, 1 represent female, and 2 represent maybe prefer not to mention my gender. The same with category, job category, like let 1 represent custodial, 2 represent clerical, and 3 represent managerial. And however you exchange this number doesn't matter, because these numbers have no values. They are just for labeling. Okay? Let's talk of ordinal scale of measurement. Assign numbers to objects, just like nominal. But here, numbers have meaningful orders, but the interval between the numbers are unknown. An example is a Likert scale. Let's, for example, I want to evaluate how this class is. And I'm saying, 1, you say, I strongly agree or I strongly are satisfied with the class. And 10 says, strongly satisfied with this class. And I know for sure that if someone has rated me 9 and another person has rated me 8, the one who have rated me 9 has rated me higher than someone who has rated me 8. And if someone has rated me 3 and another person has rated me 4, I know 4 is better than 3. But the difference between 4 and 3 might not be the same as the difference between 8 and 9. These values between 3 and 4 and 8 and 9 are not the same. So in that case, we are having now ordinal level of measurement. The same as if someone tells you someone is diagnosed with cancer level 2, another person is diagnosed with cancer level 4. These two levels are different, and the one who is at 4 level is on the verge of dying, and the second level has a few years to live. And now you cannot tell the exact difference between cancer level 1 and 2 and cancer level 3 and 4. That differences differ and no one can tell. Ordinal scale of measurement. We have interval scale of measurement. Now numbers have orders, just like we have said in ordinal. But there are equal intervals between adjacent categories. Again, now we know the difference between 3 and 4 is the same as the difference between 8 and 9 under intervals. But 0 doesn't mean absence of property. That is where you draw the line. For example, for a temperature 79 and 80 the difference between 79 and 80 is equal to the difference between 32 and 33 degrees Celsius. But 0 doesn't mean we don't have temperature. 0 still means 0 degrees Celsius, and it doesn't mean we have no temperature. Hopefully that makes sense. Ratio scale of measurement. Now when we talk of ratio scale of measurement, the differences are meaningful, like interval. So you have intervals. 1, 2. The difference between 1 and 2 is equal to the difference between 9 and 10. Intervals are there. Plus ratios are meaningful. And that is true because 0 means 0, or 0 means absence of the property. For example, weight of 12 kg is twice as, no, this one should be 6. 12 kg is twice 6 kg, and 0 kg means absence of the weight. So here you can now understand we have nominal, we have ordinal, we have interval, we have ratio. So every variable that you are collecting from your subject falls in either of these: nominal, ordinal, interval, or ratio. And you have to understand it before you go even create your data dictionary, which we are going to discuss in our next class. So I've given you again an example here of the data type and how they are divided. And you can also have a look at what each of interval, ratio, ordinal, nominal represent, and also we have given some examples there. I hope this class is helpful. Thank you and enjoy learning.